Hi guys, today we are going to talk about kinematics in one dimension. Consider an object moving with variable velocity. In the diagram here, the object A is moving along the x-axis and at a certain moment of time has a positive displacement, that is s equals plus 5. This is our origin here and this is our object A here. Because it is moving in a negative direction, its velocity is v equals minus 2. As we know, velocity is a vector. But the speed of the object is the magnitude of its velocity and is always positive. The speed of our object A equals 2. Let's get to another example. The displacement of an object B between times t1 equals 4 seconds and t2 equals 6 seconds is s1 2 meters and s2 8 meters. So here the average velocity is change of the displacement over time, that is s2 minus s1 over t2 minus t1, which gives 6 over 2, 3 meters per second. Generally, since the velocity vector changes with time, the velocity is the first derivative of displacement. That is, v of t equals the first derivative, that is ds over dt. In the same way, the acceleration is the first derivative of vt. So acceleration with time is dv over dt, or the second derivative of st, that is at equals d squared s over dt squared. Using the chain rule leads to another expression for acceleration, that is a equals dv over dt, which is dv over ds times ds over dt. And note that here these two can eliminate to give dv over dt. And substituting ds over dt with v, we have another expression for the acceleration, that is a equals v times dv over ds. This formula is useful when velocity is given as a function of displacement. Now, to apply all these equations, we shall solve an exercise. So, the height in meters of a rocket projected vertically into the air until it returns to the ground is represented by the function h of t equals minus 0.11 t squared plus 1.32 t plus 1.5, where t is the number of seconds after the rocket was launched, and t is greater or equal to 0. The first question here is state the height at which the rocket was launched. Before doing this, we can sketch the graph of this function, the curve, using our GDC. It is something like this here. You can see the motion of the rocket. Now, the height at which the rocket was launched is when t equals 0, that is h of 0 is 1.5 meters. This is the point here. The second question is find the maximum height reached by the rocket. The maximum height will occur when dh over dt equals 0, that is when velocity equals 0. So the first derivative of h equals 0. Finding the first derivative gives minus 0.22 times t plus 1.32, and this will become 0. And solving this equation, we get t equals 6 seconds. Here, the rocket has its maximum height. And to find the maximum height, what we must do is to put t equals 6 in this equation here. So h of 6 is 5.46 meters, which is this point here. Okay, the next question is calculate the velocity of the rocket at time t equals 7.5 seconds and state whether it is ascending or descending at this time. Now, using the velocity equation, which is v of t equals minus 0.22 times t plus 1.32, we substitute at t equals 7.5, and we get v of 7.5 equals minus 0.33 meters per second. This means that the velocity is negative, so our rocket is descending, as we can see here on this graph. Okay, and let's get to the final question. Find the other time at which the rocket is traveling at the same speed as when t equals 7.5. The rocket has the same speed, so its velocity is plus or minus 0.33, as we can see here. We already know where it is minus 0.33, so we need to solve v equals 0.33 with plus. That is this point here. So 0.33 equals to its velocity, and from this equation we can find t equals 4.5 seconds. Thank you for watching this video.